So now we're going to do Leetcode question number 9, which is called palindrome number. Okay, what the question says is, given an integer x, return true if x is a palindrome integer. An integer is a palindrome when it reads the same backward as forward. For example, 1 to 1 is a palindrome while 1 to 3 is not. Okay. So basically what a palindromic integer is, or a palindrome in general, is that it should read the same forward as it does backward. Or in other words, the integer or string or whatever that you have should be the same as the string or integer reversed. Okay. So for example, if I look at 1 to 3, the reverse of this would be 3 to 1, right? These both of these are not equal. So that's why it's not a palindromic integer. But 1 to 1 and the reverse of 1 to 1 is also 1 to 1, right? So both of these are equal. That means it is a palindrome. So let's try to gain some insights about this problem and develop an algorithm for it now. So before we formally write down our algorithm, let's at least try to develop the ideas that it's going to be based on. Okay. The first thing is that if you have a negative number, let's say minus 99 or minus 919, okay, irrespective of whether this magnitude is a palindrome or not, your negative number cannot be a palindrome. Okay. Because if you try to read it backwards, what you're going to see is 919 minus, right? So you're going to see this in every negative number, this pattern, that the minus in the front comes at the back now, and which is why these two numbers won't be equal, or this number won't be palindromic, right? So that's what we see about negative numbers, that if the input that is given to you is a negative number, then we always have to return that it's not a palindrome. So we always have to return false, right? So the only thing we're left to deal with now is non-negative numbers. That means 0 and positive numbers, right? So let's say that we are given a number like 2731. Okay. Now, what I want to do basically is that I want to reverse this number. Okay. So let's say that this was the original number I am given. Now I want to find out the reversed number. Okay. But I want to do this without creating this, without converting this integer into a string. Okay. So how would we do that? Let's try to actually see what is kind of happening. What do I mean by reversing the number? So what I mean by reversing the number is, first I want to take this 1 here, right? Then I want to put this 1 here, right? And then I want to forget about this 1, okay? Or I want to remove it. Then I come at 3, okay? Then I want to put this 3 at the end of this new number, reverse number, okay? That means I want to put 3 here, right? And after I've put 3 here, I can again forget about this number, right? Then I want to look at 7, okay? Again, I want to add this to the end of this new number, okay? So that means I want to add it here. And after I've added it here, I want to again forget about this 7. And finally, I come to 2 and I want to add this 2 to the end of this new number and then forget about this number, okay? So now the reversed number that I'm getting is 1372, right? And the original number that I started off with was 2731. You can clearly see that this number that I get after doing the process that I just showed you is in fact the reverse of this original number, right? It is in fact the reverse of 2731. So these are the steps that we kind of want to do, right? Which means the first step that I want to do is take the last digit of this number. So take the last digit, right? And then put it at the end of this reven number, right? And then remove it from this original number. Okay, so what we're going to discuss now is how we actually do these three steps mathematically, right? Because we can't convert this into strings and then perform these three steps. That would just completely defeat the purpose of what we're trying to do. So we're going to see how to do these three steps using math. Okay, so the first step, let's talk about the first step. Okay, take the last digit. How do we do that? For any number, okay, let's say you have any number like 738. If I want to find the unit digit, okay, the unit place digit, what I have to do is find the remainder of this number with 10, which means if I divide it by 10, what is the remainder going to be? And obviously that's going to be the unit digit, right? So all I have to do to find this unit digit or the last digit of ORGN is take the modulus of it with 10, right? And this will give me 1. So for the first step, what I can do is do n mod 10, right? Or ORGN mod 10. And that will give me, that will return a digit, right? That digit will be the last digit. So that's what I wanted to do, right? Now, the second thing is put it at the end of reven. Okay. So for, if you're just like, if in the beginning reven is empty, like we haven't even shifted one digit from ORGN to reven, then we can just directly put this number here, right? We can just directly put reven here. But what if there was already something, like what if we're on step 3 of this? So we've already put 1 and we've already put 3. And now we're trying to put this 7 number. We're trying to shift this 7 number from ORGN to reven. So how would I shift it? So this number right here is 13, right? And this digit that I found using my first step is 7. Okay. What I want to do is I want to put 7 to the end of this reven number. Okay. So the new number that I'll get is 137, right? If I put 7 at the end of that number. Now 137 can be thought of as 130 plus 7, right? And 130 is nothing but 13 into 10. Okay. So this 137 that I want to make out of 13 is just 13 into 10 plus 7, right? So that's what I'm going to do. So what I'll have to do is I'll have to do reven into 10. Okay. Doing reven into 10 will kind of shift, will make it 130, right? So it's basically shifted these digits one place value ahead and made a spot free for my units digit. Okay. And now in this units digit, I can add 7. So I'll get 137. So that's how you'll put this digit that you extract from ORGN at the end of reven. Okay. So that's going to be reven into 10 plus this digit D. Let's say if this digit is D. Okay. So this should be the new value of reven, right? So we'll just write reven is equal to reven into 10 plus D. Okay. Now, finally, what we have to do is remove it from ORGN, which means remove D from ORGN, right? So how would we do that? How would we remove this 7 from ORGN? What we're going to do is, if we have a number like 27, I want to basically convert it to 2, right? For any number, you should notice that this is actually the quotient that you get when you divide it by 10. Okay, so let's say I have any number 7, 8, 6, 5. Okay, and now I want to remove this last number. Okay, so all I need to do is divide this number by 10 and take the quotient. So when I divide it by 10, the quotient I'll get is 786, right? And that's what I wanted. I wanted to just remove this last number. So that's how you remove the last digit from orgn. Okay, you just divide it by n and take the quotient. Okay, and how do we take quotients? We do integer division, right? So all I have to do is orgn divided by 10. Okay, integer division, and this should be the new value of orgn, right? And once I've done this, I found the new value of orgn, which will be 2, and 7 will be appended to reven in step 2. And in step 3, I'll remove 7 from here, right? So this orgn will become, from 27, it became 2. Now I want to again repeat this process, right? I again want to take the last digit of orgn, put it at the end of reven, and remove it from orgn, right? So these 3 steps will actually be in a loop. Okay, these 3 steps will actually be in a loop, right? Now, so we'll have a loop from step 3 back to step 1. And with this new value of orgn and reven, we'll repeat the process. Okay, but when do we stop? When do we stop this loop? So to see that, we'll actually have to see what happens to orgn when it actually has the last digit left there, right? So 2137 was our number, and we've taken the last 3 digits and reversed them, right? Now we're left with the this final digit that we have to put at the end of reven. So we do the first step, which is take the last digit. Then we do the second step, which is put it at the end of reven. Okay, and then so we get 1372 using these 2 steps. Then in the last step, we do this, right? orgn is equal to orgn by 10. Okay, in integer division. So when you do that with 10 or any single digit number, what you'll get is 0, right? So the new orgn will actually become 0. Okay, and this is when you are not left with any more digits to deal with. Okay, so when orgn becomes 0, that means you've dealt with all the digits of orgn, and you should end your loop there. Okay, so like you might come up with the question that what if 0 was actually a part of orgn, like what if we were left with 0 2. Okay, now if we take 2 and then put it behind reven, okay, and then divide 0 2 by 10, we'll again get 0 as the answer, right? But we were still left with processing this one digit that orgn had. So the trick behind this is that this situation will never even happen, because orgn is actually an integer, right? And these integers, they don't have leading zeros. So our number will never be something like 02731 or 002731, right? It will only be 2731 and won't have any leading zeros. That's why such a case won't exist. Okay, so ending the loop when orgn becomes 0 is what we should do, and that is correct, right? So that's fine. But what if we have what if we have a case where orgn has trailing zeros instead of leading zeros? That's allowed, right? What if we have something like 200, right? In this case, when I'm actually trying to reverse my when I'm actually trying to reverse orgn and store it into reven, right, then I should actually get something like 002, right? If I do it properly, like if I consider this as a string and try to reverse it, this is what I should get, right? But we know that reven is also an integer, right? So it's not going to be able to have these leading zeros, right? So when orgn has trailing zeros, it does become a problem for this algorithm. Okay, the exact place where the problem comes in the algorithm is in step 2. Okay, because let's just see what will happen. So suppose I had just something like 20. What's going to happen is rev n is going to be 0 initially, right? Because that's like null. It's like it has nothing right now in it, no digit. So what's going to happen is our algorithm is going to extract this last digit, and it's going to perform step 2 after that, right? So step 2 says that we have to multiply the current value of rev n by 10 and add this new digit to it. This is going to give us 0 again. Okay, so and then in step 3 we can remove 0 from here. So it seems like we've shifted this 0 from top to rev n, but actually we haven't, because now with 2 what is going to happen is that if I try to do step 2 for 2, then what will happen is that rev n will be equal to 0 into 10 plus 2, right? This is going to become 2. So after the third step happens for 2 also, the 2 is going to be gone from here. So this will become 0 and rev n is going to be 2, right? Rev n will be 2, not 0 2, right? Because this 0 into 10 doesn't actually allow us in shifting a 0 to the left, right? It just nullifies this into 10 process that we do, which is actually the shift. So trailing zeros are a problem in our algorithm, right? So what do we do for that? It's actually really simple. We just have to think about what we're trying to solve. We're trying to solve for palindromes, right? That means they should be the same if you read them forwards or backwards, right? And we already discussed that ORGN can never have leading zeros, right? So even if ORGN has a few trailing zeros, we know that it can never have leading zeros, right? So these zeros are not going to be uh, replicated in the front part of ORGN. Okay, this part won't have leading zeros, but this part will have trailing zeros, right? Which is why if ORGN does have a trailing zero, even one trailing zero, then we know that it can't be a palindrome, right? So that's all. These are all the ideas that we needed for discussing uh, how to solve this problem. We can go ahead and formally write down our algorithm now, so that it's a little more clear in our own brains and also in my explanation that what we're actually going to do step by step. Okay, so what we're going to do is write the algorithm just in as a set of instructions. Okay, like an instructions in words or something like that. This is kind of a form of something known as pseudo code, in which it means that you're not actually coding, but you're writing a code that can be implemented easily in any programming language. So the first thing we need to do is make a variable orgn, right? And this is going to have the value of n, which is our input, right? Now, one of the cases that we have to check is if orgn is less than 0, then false, right? So if we have a negative number, then we know that it can't be a palindrome ever. So that is one thing. Another thing is if orgn mod 10, okay, is 0, that means if orgn has even one trailing 0, then also it can't be a palindrome, right? Because it has no leading zeros because it's an integer. So if it has a trailing 0, then it won't be a palindrome, because that trailing 0 won't be matched in the front of the number. Okay, so now, and after dealing with these two special cases, or also known as edge cases sometimes, okay, after dealing with these two edge cases, we can get to our main program, which is executing these 3 steps in a loop. Okay, so to do that, we also need to initialize rev n to 0, right? So rev n is the number that will store our reversed input. Okay, and then we just have a loop. So while orgn is not equal to 0, like we discussed, we have to do these 3 steps. So the steps are just written here, right? D is equal to orgn mod 10, which gets the last digit in orgn. Then revn is equal to revn into 10 plus d, which fits that last digit onto the back of revn. And finally, orgn is equal to orgn upon 10, which removes that digit from orgn. Okay, and we keep executing this loop. Okay, so this can be statement 6, 7 and 8, or 5.1, 5.2, 5.3, however you want to think of it. And after this, once we have the reversed integer and the original integer, all we need to do is check if revn is equal to orgn, then it's a palindrome, right? So we return true, else false, right? So that's it. That's our algorithm. That's the pseudocode for it. And now all we need to do is code this up in Python, which is going to be fairly easy now that we've even written a pseudocode for it. So let's start writing the code now. So the first thing we have to do is take orgn and set it to, oh, I'm sorry, where I started writing the code, right? So the first thing we have to do is take orgn, or original n, and set it to our input, right? So the input here is x. Okay. After that we need to check 2 things. If orgn is less than 0, then return false, right? So if orgn is in fact less than 0, what the function will do is directly return false and go out of the function, right? So we don't need to write an else statement here. Okay, because only if orgn is greater than 0 will it ever reach line 7 in the code. Okay, so then we can here again write if orgn mod 10 is equal to 0, then return false again, right? Similarly, so yeah, those are our 2 edge cases. After that, we can just start off with our basic algorithm, right? Which is trying to reverse this number. So revn is equal to 0 to just initialize revn. And then after that, while orgn is not equal to 0, the first thing we do is extract the digit. So orgn mod 10, right? The next thing we do is add this digit to the back of rev, right? And finally, we remove this digit from orgn, right? And this keeps running, and finally we have the reversed number in revn. Okay, once we have the reversed number in revn, all we need to do is check if revn equals to orgn, then then return true, right? Else return false. So that's it. That's our whole code, and this should run if we haven't made any small typing errors or things like that. Let's try to run it. Okay, so there is some problem here. Let me just try to think about this for a second. Yeah, so what we're missing here is that we need to compare revn with the original number that was given to us, right, with our input. And even though in step 3 we did store that input in orgn, we went ahead and did a lot of operations in orgn, right? And eventually orgn became 0, as you can see here, right? So we don't have to compare revn with orgn. In fact, we have to compare it with our input x. So once we make that change, let's try to run it. And yeah, it does work. So let's try to submit it to see if it works on all the cases. right? Now it gives a false or a wrong answer for 0, okay, which means that there is something wrong in our code. So what is wrong in our code? The thing that's wrong is when the input is 0, it's going to return a false, right? Because we're saying that if org and mod 10 is 0, then return false. But we only need this statement, which means statement 7 and 8. We only need this if we actually have a number that has trailing zeros in it, right? But if that number itself is 0, then the trailing and the leading 0 become the same thing, right? So in that case, we shouldn't return false. In fact, we should return true, because 0 is a palindrome, right? So before checking for trailing zeros, I should actually check if orgn is equal to 0, right? And if it is, then directly return true without going forward. And now this code should be complete. So let's try to submit it. And it does work. So that's all for this video. Thank you everyone for watching, and I hope it was clear. Yeah. If you have any doubts, feel free to leave those in the comments.